Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Makrudin. Representing my team, there is Dr. Umar Atika Muhammad Roslan, my supervisor, and also Dr. Muhammad Uzir Rosli and Dr. Muhammad Hafiz Muhammad, that is acting my co-supervisor. Our title for this research is to conserve or exploit, assessing the sea turtle sustainability via mathematical modeling. So we go to the introduction first. The sea turtle is an oviparous animal, oviparous reptile with several stages, that is eggs, juveniles and adult. So among of the life stages, it is observed that the juveniles are the most vulnerable stages, as the adult sea turtles will lay their eggs in clutches, and they will lay their eggs around the same time. Also, they will hatch around the same time and in the same area, which makes them the easy prey by the other organism. The disease such as the ghost crab, the monitor lizard, white dogs, and many more. There is estimated only 1 in 1,000 hatchlings will survive to adulthood and reproduce. There are two beach uh, beach activities, that is the exploitation and conservation activities. The exploitation activities are the illegal poachers, heavy employment development by the shores, and also the light and sound pollution. For the conservation activities, the Terengganu Sea Turtle Enactment in 1951 for the loggerhead sea turtle eggs, the DRF by the sea turtle eggs for the lazy. There are also NGOs that manage the sanctuaries, and also there have been volunteer and adaptation programs by various entities. Next, we go to the objective. There are two objectives. First is to synthesize a state structure preparatory model that is compromise the effort of conservation and exploitation. The second one is to determine the long-term behavior of the sea turtle population from the model. We go to the methodology. There are several assumptions of the model. The first one is the conservation and exploitation rate. We represent the conservation parameter as alpha 1, and also the exploitation parameter as beta 1. It is assumed that it is have been severe relative positive and negative effort towards the model. Number 2, the state structure life cycle model. So we separate the two life cycles of the model, that is the X and the hatchling, represented by X and Y. The sea turtle have such chances to reproduce R, and also they have the cap number of uh, capacity number, that is the K. And also we have the third assumption, that is the predation and natural death. The fish predator is represented by Z, and every X, Y, Z have their own natural death rate. Z is responding to predation via certain hatchling density of Y. This is the flow diagram of the interaction according to the assumption before. This is the model that has been synthesized, that is shown by dx, dy, and dz. This is the desired variable that we have to find in this project, and also this is the parameter of the model. The result and discussion. There are three possible steady state of the model. The first one is the total extinction, which is non-favorable for this model. And we also have the predator-free environment, and also the coexistence of all the situated life stages and the predators that is represented by X star, Y star, and Z star. The equation of of the of of the coexistence are represented by X, Y, and Z here. So we move on to the time series interpolation for the case alpha 1 is more than beta 1. Here we can clearly see there exists a limit cycle for every 100 time frame according to this parameter, that is alpha is 0.99 and beta is 0.1. Also the parameter has been stated here, and also the references. We tweak the value when alpha is still 0.99 but the beta is 2.0, and also the parameters are remain the same. We can see the limit cycle behavior has been disappeared. So this is the first time diagram with flow uh, flow trajectories of the model. The left hand side is when the alpha 1 is more than beta 1, and the left hand side is the alpha 1 is less than beta 1. So we can see ultimately this on the left hand side the trajectory will show a cycle, but on the right hand side the cycle has been disappeared. As conclusion, we we can see the irreversible damage may occur to the population dynamics if the beach activity is not balanced, especially when the value of exploitation is higher than the value of conservation. This provides the insight for the sanctuaries for the future plans, and also the result may be compared with real data and other types of modeling, such as agent-based modeling, statistical models, and hybrid models. We would like to thanks to the Mr. Meshi Terengganu and Ministry of Education as the patron for this paper to FRGS Wood 59573.